So just to recap, in the beginning, there are some weaker children, and they take the smaller boxes in. And then, most of the children, they take the boxes which have a medium amount of paint in. And then you get the very, very strong children. The very strong children manage to take in the pink boxes, and the pink boxes contain 7 tins of paint each. But the yellow boxes are extremely heavy. And there are no children in the school who are strong enough to take these boxes in. So those boxes stay in the lorry. And that's really how light works as well. Because in the beginning, as the frequency increases, along here the frequency is increasing, the intensity or the energy is increasing, right? And then we get to here, and it goes back down to 0 again. Now, you're probably a little bit confused at the moment because, you think, well, light, it doesn't come in boxes, does it? Yes. But actually it does. Light does actually come in boxes. It actually comes in packets of energy. And the higher the frequency, the larger the packets of energy are. And this packaging of light, we actually call that quantum mechanics, because light comes in set quantities. So you've probably heard of the term quantum mechanics before, but what does it actually mean, quantum? Well, quantum means a whole number. Let me try and give you an example. If I asked you how many sisters do you have, or how many brothers do you have, you might say, oh, I have 2 brothers, or I have 3 brothers. But you would never say I have 2.5 brothers. Yes, it's got to be full numbers. Yes, you can't say, oh, I've got 1.5 sisters. Yeah, you can say you've got 1 sister, or you've got 2 sisters. So light behaves exactly in the same way, and it sort of comes in quantum packages, and these packages are called photons. And it's a property of light that you don't get 1.5 photons or 3.7 photons. Photons come in full, complete numbers, like 1, 2, 3. No decimal places, no 3.7 or 4.8. It's just whole numbers. And as I said before, if you increase the frequency, the larger these packages of energy get. So let's say you heat up an object in the oven. So let me draw an oven. Yeah, let's say you put a piece of metal in the oven, your normal oven, not your microwave oven. Don't go putting metal in your microwave oven. But let's say you put a piece of metal into your oven, you start heating it up. The metal is going to start to emit heat, yes, so it's going to get hot, and it's going to start emitting heat like this. And it's going to do it at different frequencies. So let's go back to our spreadsheet again. So these are the different frequencies, and as we said, yeah, the higher the frequency, the bigger the package. So in the beginning, it's quite easy for your piece of metal in the oven to start emitting the lower frequencies. But as the frequencies get higher, it's more difficult for your piece of metal to start emitting the higher frequencies, because the packages are much bigger, and because the packages are much bigger, they're much more difficult to be put into use, which is why we get a graph this shape. So in the beginning, at the low frequencies, it's quite easy for the piece of metal in the oven, the hot piece of metal, to emit these frequencies. But as the frequencies get higher, up towards the ultraviolet sort of frequencies, the packages of light are just too big. The photons are just too big, right? And it's very difficult for those packages to be used. and so the energy level dies down again. So this shape here, you can see, it's called a black body radiation shape. Let's go back to our original picture. Yeah. So this the blue shape here, yes, is called a black body radiation shape, and it doesn't matter what temperature something is. Yes, all things at different temperatures will emit heat, yeah, in this sort of shape. Yeah, so at the beginning, as you increase the frequency, the energy level gets higher, but as you get towards the ultraviolet frequencies, the energy level dies off. And that's the same of objects at all different temperatures. So it doesn't matter what the temperature is, generally you're going to see this shape here. Okay, next lesson we're going to be actually talking about black body radiation, and I'll explain a little bit more about what it is. Okay, see you next lesson.